What if everything we know about history is just the tip of the iceberg, and the real story of Earth began long before the dinosaurs ever roamed? We imagine ourselves as the first intelligent species, but Earth is over 4.5 billion years old. Humans have been around for a blink. Dinosaurs ruled for hundreds of millions of years. But what about the billions of years before that? What happened in those deep forgotten ages? Could there have been another civilization, intelligent, advanced, and now completely erased from time, not alien, not future, but ancient, and from Earth? This isn't science fiction. It's a real question scientists are starting to ask, and the answers may shake the foundation of what we think we know. The impossible question. Every so often, a question slips quietly into your mind, one that seems too strange to be true, too big to even consider seriously. But once it's there, it won't leave you alone. It keeps echoing, getting louder the more you try to ignore it. One of those questions is this: what if we're not the first intelligent civilization on Earth? Not the first to invent tools, build cities, or even launch technology into the skies? What if, long before the dinosaurs, another species lived on this planet, intelligent, organized, advanced, and then disappeared so completely that we've never found a trace? At first, it sounds ridiculous, like something from a sci-fi novel or a conspiracy theory. But then you remember something: Earth is very, very old. About 4.5 billion years old. That number is almost meaningless to the human brain. It's too large to visualize. If the entire history of Earth were squeezed into a single calendar year, humans wouldn't appear until 11:58 p.m. on December 31st. Dinosaurs, they lived from around December 13th to December 26th. That leaves a lot of time, months, even, where something else could have happened. And we have almost no idea what it was. We tend to think of history as a straight line. First came the dinosaurs, then mammals, then humans, and here we are with smartphones and space stations. But that version of history is more like the last few pages of a very long book, and most of the earlier chapters have been lost, torn out by time. The fossil record is patchy. Rocks get crushed, recycled by tectonic plates, eroded or buried under kilometers of sediment. Most life that ever existed left no fossil at all. Most of Earth's surface from hundreds of millions of years ago doesn't even exist anymore. It's been melted down in the planet's mantle or destroyed by earthquakes and shifting continents. So if there was an advanced civilization hundreds of millions, or even billions of years ago, how would we know? Would we expect to find buildings, machines, metal tools, or fossilized cities? Maybe not. Maybe those things wouldn't survive. Maybe they already came and went, and we've been walking over the ruins without realizing it. That's the impossible question. Not did dinosaurs build computers, or were cavemen astronauts, but something deeper and more unsettling. Would we even recognize the signs if a pre-dinosaur civilization had existed? Could we tell the difference between natural geological formations and the weathered remains of some ancient intelligence? And are we too quick to laugh off the idea, just because it doesn't fit into the tidy timeline we've grown up with? This question isn't new. It's been whispered about for decades, mostly in science fiction or fringe theories. But recently, even some mainstream scientists have started to take it more seriously. In fact, in 2018, two respected researchers, Gavin Schmidt, a NASA climate scientist, and Adam Frank, an astrophysicist, published a scientific paper about it. They called it the Silurian hypothesis, named after a fictional reptilian race from the TV show Doctor Who. Their idea was simple. If an industrial civilization had existed millions of years ago, would we be able to detect its presence in the geological record today? Their conclusion was both fascinating and unsettling. Maybe not. Because the Earth is so good at wiping itself clean, rain, wind, shifting tectonic plates, they don't just erode cities, they erase them. Over tens of millions of years, even the most dramatic signs of life, concrete, metal, bones, break down, they vanish. What's left are only indirect clues, chemical signatures in the rocks, odd isotope patterns, traces of unusual carbon activity, and even those are easy to misinterpret, or attribute to natural causes. So we're left with a strange possibility. Not proof, not even a strong hint, but a question that refuses to go away. What if there was once a species, not human, not alien, but earthborn, that achieved something amazing, long before we ever came along? What if they built, discovered, reached heights, and then fell into silence? Not because of a single disaster, but because of time, deep time, time so vast, it doesn't just kill civilizations, it buries them so deep, we forget they ever existed. You don't need to believe in ancient astronauts or lost continents. You just have to look at the numbers. Earth is 4.5 billion years old. Complex life has existed for more than 500 million years. Humans have been around for less than 1% of that time, and industrial civilization, a few hundred years. So ask yourself, are we really the first, or just the first we can remember? That's the journey this video will take you on. A quiet, rational exploration of a radical idea, not to prove it, not to sell it, but to show that maybe, just maybe, it's not as impossible as it first sounds. What we think we know, most of what we believe about Earth's past, isn't from direct experience. It's from models, textbooks, fossil records, and educated guesses. Our understanding of history feels solid because it's been repeated so many times. From childhood, we're taught that life evolved in stages. First came simple, single-celled organisms, then fish, then amphibians, reptiles, dinosaurs, mammals, and finally, it's a clean, linear path. The truth, though, is far more complicated and far less certain. Our timeline of Earth is built mostly on what we've found, not necessarily what existed. Fossils are incredibly rare. To even have a chance of fossilizing, an organism has to die in the right place, at the right time, under the right conditions. Then, over millions of years, it must survive the constant forces of erosion, pressure, earthquakes, heat, and tectonic destruction. Most creatures that ever lived left behind no fossil at all. They came and went without a trace. That includes not just animals, but entire environments. Whole ecosystems have vanished without a record. Imagine an ancient rainforest teeming with life, filled with species we've never seen. If it existed on a continent that has since sunk beneath the ocean or been subducted into the Earth's crust, it's gone. No clues, no bones, no evidence. It's as if it never happened. And yet, we build our timelines from the evidence that survived, the few pieces of the puzzle that just happened to last. That's the first important point. What we think we know is based on what we've been lucky enough to find. There's a name for this problem, the preservation bias. It means the record we see is skewed toward things that fossilize well: bones, shells, teeth, softer tissues, wooden structures, clothing, buildings. All of those things disintegrate quickly, and over tens of millions of years, even the hard stuff doesn't hold up. So when we say there's no evidence of an advanced civilization before humans, we're making a statement based on absence. We're saying we haven't found it, not it never existed. That may sound like a small difference, but it's actually massive. The absence of evidence is not the same as evidence of absence, especially when you're dealing with a planet that constantly recycles itself. Now let's zoom out and look at the actual timeline. Earth formed around 4.5 billion years ago. Life began early, probably within the first billion years. For most of Earth's history, life was microscopic. Single-celled organisms, algae, and bacteria ruled the planet for billions of years. Then, around 600 million years ago, something changed. Multicellular life exploded in diversity during what we call the Cambrian explosion. That sounds recent, but it's not. Dinosaurs didn't show up until about 230 million years ago. Humans have only existed for about 300,000 years, and modern civilization. We've had electricity, engines, and satellites for just over a century. That's not even a blink in Earth's timeline. If the planet were a clock, human civilization would be less than a millisecond on the dial. So here's the second important point. There's a lot of room in the timeline for something else to have happened. Hundreds of millions, even billions of years, where intelligent life could have risen and fallen without us knowing. But here's where it gets tricky. Even if a pre-dinosaur civilization had existed, we expect that we'd find their buildings, their tools, their art. But would we? Think about it this way. If humans disappeared tomorrow, how long would our civilization last before it was unrecognizable? Most plastics would break down in a few centuries. Steel buildings would rust and collapse. Glass would shatter. Paper and fabric would rot away in years. Even concrete, which feels permanent, would crumble in a few thousand years. The tallest skyscrapers would be gone. Roads would be buried. Satellites would fall from orbit. Within a million years, very little would remain. Within 100 million years, probably nothing at all. Geologists estimate that the oldest surface rocks still exposed on Earth are about 4 billion years old, but they're extremely rare. Most of the crust is younger than 200 million years because of plate tectonics, the slow but constant recycling of Earth's surface. This means that even if a civilization existed 300 million years ago, the land they built on might have been dragged under another continent or melted in the mantle. It's gone, erased not by disaster, but by time. So what we think we know is based on a narrow window, a small, scattered, fragile collection of fossils and rock layers. We fill in the gaps with logic and probability. And in most cases that works. But sometimes, when we look too closely at the map we've drawn, we forget how many blank spaces are still there. We confuse the picture with the territory, the model with the truth. And that's where this story begins. In the gaps. In the billions of years we don't fully understand. In the possibility that intelligence has visited Earth before, not from the stars, but from deep within its own forgotten ages. If that's even remotely possible, then we have to rethink not just where we came from, but how much we've truly lost. Earth's deep past. To even begin imagining a civilization before the dinosaurs, we first need to step into a kind of time that feels alien, not just ancient, but almost beyond human comprehension. This is what geologists call deep time. It's not measured in lifetimes, or centuries, or even in the rise and fall of empires. It's measured in millions and billions of years. And when you look at Earth through that lens, everything we know starts to feel very temporary. We're used to thinking of the dinosaurs as unimaginably old, but they only appeared around 230 million years ago, in the late Triassic period, and they were gone by about 66 million years ago, after the asteroid impact that ended the Cretaceous. That means dinosaurs existed for roughly 165 million years. For comparison, modern humans, Homo sapiens, have existed for less than 1% of that time. Not industrial civilization, just the species itself, Everything we think of as history, from the pyramids to smartphones, has happened in a tiny sliver at the very end. Now consider this. Before the first dinosaur ever took a step, the Earth had already gone through 3 billion years of life. 3 billion. That's over 90% of our planet's history. And in that vast stretch of time, entire worlds came and went. Continents formed and broke apart. Oceans appeared and vanished. Mountain ranges rose and eroded back into plains. And through all of it, life kept evolving, sometimes slowly, sometimes in bursts, sometimes collapsing entirely during mass extinctions. Let's walk backward. Before the dinosaurs came the Permian period, known for its strange, often mammal-like reptiles, creatures like Dimetrodon, with its sail-shaped back. The Permian ended with the largest mass extinction in Earth's history, the Permian Triassic extinction event, around 252 million years ago. Over 90% of marine species and 70% of land species were wiped out. Scientists still debate what caused it. Maybe massive volcanic eruptions, maybe methane releases, maybe both. But whatever happened, it nearly sterilized the planet. Before that was the Carboniferous period, about 360 to 300 million years ago. The world was swampy, lush, and oxygen-rich. Giant insects roamed the skies, dragonflies the size of seagulls. Huge forests covered the land, which would later become the coal beds we mine today. It was a time of dense ecosystems and abundant life. Then came the Devonian, often called the Age of Fishes. Before that, the Silurian and Ordovician periods, where early sea life exploded in diversity, and the first plants began to colonize land. And before that, even earlier, was the Cambrian, over 500 million years ago, when multicellular life really took off. The Cambrian explosion brought about many of the basic body plans we still see today: segmented creatures, hard shells, primitive eyes. But all of this, even the Cambrian, is recent compared to what came before. The vast stretch of time before the Cambrian is called the Precambrian, and it covers almost 90% of Earth's entire history. That's nearly 4 billion years of Earth's life before complex animals appeared. Most of what we know about it comes from ancient rocks, rare microfossils, and chemical clues. It was a world of microbial mats, single-celled life, and slow geologic changes. But even there, strange possibilities remain. One of the earliest events in Earth's biological history is something called the Great Oxygenation Event, about 2.4 billion years ago. Before this, the atmosphere had almost no oxygen. Then photosynthetic bacteria started producing it in massive amounts, completely transforming the planet's chemistry. But here's the thing: oxygen is toxic to many forms of life. So this great event was also a kind of apocalypse, a planet-wide extinction for earlier oxygen-intolerant life. In other words, Earth has a long track record of wiping itself clean, not just physically through erosion and subduction, but biologically by shifting the rules of survival. And during all these eons, the continents never sat still. Thanks to plate tectonics, the Earth's land masses have constantly moved, crashing into each other, breaking apart, drifting across oceans. Hundreds of millions of years ago, there was a supercontinent called Pangaea. Before that, there was Rodinia, and before that, Columbia and Kenorland. Each time the crust of the Earth reshaped itself, and any trace of what lived on those ancient surfaces was pushed deep underground or destroyed entirely. So if you imagine an ancient civilization, not 10,000 years ago, but 300 million years ago, you have to imagine it living on land that might no longer exist. land that was later buried, burned, or pulled into the mantle. Its cities could have been built on a continent that's now part of the ocean floor. Its people, or whatever they were, might have looked nothing like us. And everything they left behind might have vanished under the slow grinding wheel of geologic time. This is what makes Earth's deep past so mysterious. It's not just that it's old, it's that it's mostly gone. We can read some of it in the rocks, like scattered sentences from a book that's been mostly torn apart. But for the most part, we're guessing, carefully, scientifically, with reason and evidence, but still guessing. And once you realize how much we've lost, the idea that something big, something intelligent, could have existed and disappeared, starts to feel less like fiction and more like a possibility we simply haven't been able to check yet. The forgotten eons. When people think about ancient history, most stop at the dinosaurs, go a bit further, and maybe they've heard of the Cambrian explosion or the creatures from the Permian, but anything beyond that tends to disappear into a fog. The names of those earlier eras sound strange and distant. The Ediacaran, the Cryogenian, the Tonian. For most, they don't even register as real periods of Earth's story. They just feel like deep background noise. But they were real. They lasted hundreds of millions of years. And they're mostly missing from our collective understanding. These are the forgotten eons, vast stretches of time that shaped our planet, yet left behind almost no recognizable evidence of life as we know it. But just because we don't see the evidence doesn't mean those eras were empty. It just means they've been hidden by time. The Precambrian alone makes up about 88% of Earth's entire history. Let that sink in for a moment. Everything from the first dinosaurs to today fits into the remaining 12%. The Precambrian is divided into three major eons: the Hadean, the Archean, and the Proterozoic. Together they stretch from Earth's formation about 4.5 billion years ago to the start of the Cambrian, roughly 541 million years ago. That's over 4 billion years, and we barely know what happened during most of it. The Hadean eon was the Earth's chaotic beginning. Imagine a young planet still cooling, its surface a boiling ocean of magma, constantly bombarded by asteroids and debris. The moon may have formed during this time, possibly from a giant impact with a Mars-sized body. There was no breathable atmosphere, no oceans as we know them, just a violent, unstable world. And yet, even here, life may have already been trying to start. By the time we get to the Archean eon, the planet begins to settle down. This is around 4 to 2.5 billion years ago. Earth's crust solidifies. The first oceans appear, and most importantly, life begins. Simple, single-celled organisms, bacteria and archaea, take hold. These were not tiny players in a pre-human world. They were the only life forms on Earth, and they ruled for billions of years. We often think of intelligence as something that appeared late, something that needed eyes, limbs, and brains. But what if we're wrong? What if intelligence, not human-like, but something else, emerged far earlier in a different form? What if evolution, given enough time, doesn't always follow the same path we did? That brings us to the Proterozoic eon, which stretches from about 2.5 billion to 541 million years ago. It's here that things start to get more complex. The atmosphere begins to accumulate oxygen, thanks to cyanobacteria. This was the Great Oxygenation Event, and it was one of the most dramatic and deadly changes in Earth's history. The oxygen that now supports our lives was once toxic to most of the life on Earth. It caused a massive extinction, killing off species that had thrived in low oxygen environments. but it also cleared the way for new kinds of life, more complex, more adaptable, and eventually multicellular. By the end of the Proterozoic, we see the first real signs of complex life. Not fish or plants yet, but soft-bodied organisms, strange, symmetrical shapes that don't fit into any modern category. Some of these Ediacaran creatures may have been ancestors to animals, others may have been evolutionary dead ends, and then, as suddenly as they appeared, most vanished without a trace. So what does this mean for the idea of a forgotten civilization? Well, the first thing it shows is that massive changes can happen quietly, over vast spans of time. The rise and fall of entire ecosystems, even whole biospheres, can occur without leaving behind obvious evidence. Oxygen nearly wiped out all life once, and it left no ruins, no monuments, no cities, just a chemical signature in some rocks. Now imagine a civilization that didn't build in stone or metal. Maybe they were aquatic, maybe they lived underground, maybe they used organic materials that decomposed completely. Maybe their tools weren't tools in the way we understand them. In deep time, nature doesn't preserve the things we think are important. It preserves the things that happen to be hard, buried, and undisturbed. Everything else erodes, melts, breaks, or disappears. And time is relentless. The longer ago something happened, the less chance there is of finding any sign it ever existed. After just a few thousand years, wood turns to dust. After a few million, bones dissolve. After a few 100 million, even the land itself may be gone, subducted into the mantle or transformed into new rock under pressure. And that's assuming nothing else, like glaciers, erosion, volcanoes, or asteroid impacts, got to it first. That's what makes these forgotten eons so intriguing. Not because we know a civilization existed back then, but because we can't confidently say one didn't. There's too much time, too many gaps, too many questions. We look into these vast stretches of prehistory, and we assume silence means nothing happened. But it could just as easily mean we're not looking in the right way. The forgotten eons remind us of something important. The Earth doesn't owe us clarity. It reveals its story in fragments. And sometimes the biggest chapters are the ones we've never even seen. Signs in the rocks. When we want to know about the past, we look down, not just at soil or fossils, but at the rocks beneath our feet, because they are the Earth's memory. They hold the traces of ancient oceans, extinct species, long-forgotten environments, and even global disasters. The deeper you go, the older the story gets, but the farther back you look, the less detail remains. And when it comes to finding traces of an ancient civilization, one that might have existed long before the dinosaurs, the rocks are the only clues we could ever hope to find. So what should we be looking for? In our modern world, civilization leaves obvious marks: buildings, roads, plastics, metal tools, landfills, radiation, greenhouse gases. But these things are temporary on a geological scale. A building that looks permanent to us might not last more than a few thousand years without maintenance. Metals corrode, concrete cracks, plastic breaks down under UV light, and if millions of years pass, even the best preserved city would become unrecognizable or be erased entirely. Geologists and paleontologists know this. They don't just look for visible ruins. Instead, they search for indirect signs, things that suggest sudden environmental changes, unnatural patterns in chemical layers, or disruptions in the Earth's normal rhythms. These clues are subtle, often microscopic, and easy to overlook, but they can tell us if something strange happened in the deep past, even if we don't know exactly what. For example, scientists can measure the ratios of carbon isotopes in ancient rock layers. Under normal circumstances, life on Earth prefers a lighter form of carbon, carbon-12, over the heavier carbon-13. So when we see unusual spikes or dips in these ratios, it suggests a large-scale change in the global carbon cycle that can happen naturally, like during massive volcanic eruptions or the extinction of countless organisms. But it could also happen if something was burning huge amounts of carbon-based fuel, something like an industrial society. Of course, that doesn't mean every carbon spike was caused by an ancient power plant. Natural events have been shaping Earth for billions of years, but it does mean that if an earlier civilization had existed, we might be able to detect it by these chemical fingerprints, even if everything else was gone. We might also look for strange metal concentrations in ancient sediments. Modern industry leaves behind elevated levels of metals like lead, chromium, and rare earth elements. These don't occur in such concentrations naturally. So if we found a layer of rock from 300 million years ago with a sudden, localized spike in industrial metals, especially in places without volcanic or asteroid activity, that would raise questions, then there are synthetic molecules like plastics. These are long chains of carbon and hydrogen that don't occur naturally in most environments. Today, microplastics are found everywhere, in oceans, snow, even inside our bodies. But over time, they break down. UV rays from the sun, bacteria, and heat all help erase them. In a few thousand years, most plastic would be gone, but in rare conditions, say, buried under thick mud with no oxygen, tiny remnants could survive. If we found even traces of plastic polymers in rocks older than the age of mammals, it would be an astonishing discovery. Another possible sign is radioactive waste. Some radioactive isotopes produced in nuclear reactions have very long half-lives, thousands to millions of years. If an ancient civilization had nuclear technology, there might be a signature left behind in the form of unnatural isotopic ratios deep in the geological record. These wouldn't resemble anything caused by natural uranium decay or cosmic rays. But again, detecting such a thing would require knowing exactly where to look and what not to overlook. Even changes in sediment patterns might tell a story. Human civilization has dramatically altered rivers, coastlines, and landscapes. Dams, agriculture, and deforestation all leave marks in the form of soil composition and erosion. Over time, these changes get recorded in sediment layers. If we found an ancient layer where natural erosion suddenly changed into patterns resembling farming or mass land clearance, and then returned to normal, we'd be left with a mystery. Still, we must be careful. Nature can mimic civilization. Volcanic eruptions can release carbon, meteor impacts can scatter metals, ice ages and ocean anoxia events can alter sediment and chemical flows, and our data from hundreds of millions of years ago is incredibly limited. Most rocks from the deep past are buried or destroyed. The few we have are scattered across the globe, like torn pages from a book we can't fully read. This is why the question of a pre-dinosaur civilization is so hard to answer. We're not looking for obvious statues or cities. We're looking for anomalies, small, hard-to-explain signals buried in an ocean of natural processes. And we can't always tell if those anomalies are the result of geology, biology, or something else entirely. But it's those unexplained signs, the sudden chemical shifts, the missing data, the odd patterns that invite curiosity. Because even if there's no clear answer, the fact that we're still asking the question means there's something we don't fully understand. And maybe that's the most important sign of all. The Silurian hypothesis. At first glance, the idea of a civilization existing before the dinosaurs seems like something that belongs in science fiction. But in 2018, two respected scientists decided to take that question seriously. They weren't conspiracy theorists or fringe thinkers. They were mainstream researchers asking a very specific question. If an advanced civilization had existed millions of years ago, would we be able to detect it today? They called their paper the Silurian hypothesis. The name itself was a bit of a wink to science fiction fans. It came from a 1970s episode of Doctor Who, where the Doctor encounters an ancient reptilian species, the Silurians, who ruled Earth before humans, but went into hibernation underground. The show was fiction, of course, but the idea it played with, that intelligent life could have flourished long before humans, was provocative. And for scientists Gavin Schmidt, a climate scientist at NASA, and Adam Frank, an astrophysicist, it was an idea worth exploring with scientific tools. They weren't claiming that such a civilization actually existed. Instead, they were asking something even more uncomfortable. Could such a civilization have existed without us knowing? Could we miss it entirely, not because we aren't looking, but because we're looking for the wrong things, or in the wrong way? To answer that, they treated the hypothesis like any scientific problem. They stepped back and said, let's imagine a civilization as advanced as ours, or even slightly less, lived on Earth tens or hundreds of millions of years ago. What would it leave behind? What traces would survive the passage of deep time? And the answer, according to their research, was maybe nothing obvious. Their focus was on the geological fingerprint that modern civilization leaves behind. Today, our presence is written into the Earth's systems in many ways. We've released huge amounts of carbon into the atmosphere and oceans. We've deposited artificial chemicals like pesticides and plastics in soils and sediments. We've changed nitrogen cycles through agriculture. We've left behind radioactive isotopes from nuclear testing. We've altered coastlines, built massive cities, and even created new kinds of minerals like concrete and aluminum alloys that wouldn't exist without us. But here's the catch. Most of these markers are short-lived. Plastics degrade, metal corrode, urban areas get overgrown and buried. In 10,000 years, cities like New York and Tokyo would be crumbling ruins. In 100,000 years, they'd be little more than disturbed sediment. And in 1,000,000 years, they might be completely gone, especially if tectonic shifts, erosion, or sea level changes had reshaped the land. Schmidt and Frank argued that only certain chemical signals might persist for millions of years. Things like unusual carbon isotope ratios from fossil fuel burning, spikes in nitrogen due to fertilizers, sudden changes in sedimentation rates caused by widespread land use, or traces of synthetic molecules embedded in sediment layers. But even these would be difficult to detect unless we already knew exactly where to look and what time frame to target. Now apply that to the idea of an ancient civilization, one that might have lived, say, 300 million years ago. The farther back you go, the harder detection becomes, because not only do materials decay, but the Earth itself changes. Rocks are recycled through plate tectonics. Ocean floors vanish into the mantle. Whole continents drift, collide and break apart. The geological record becomes spottier and more difficult to interpret. So the Silurian hypothesis doesn't say there was a civilization before us. It says if there was one, and we aren't saying there was, we might not be able to find it. That statement alone changes the conversation. It forces us to acknowledge that our knowledge of Earth's history is incomplete, not because science has failed, but because time is a brutal editor. The further back we look, the less data we have, and that opens a window, however small, to other possibilities. The authors even noted that certain events in Earth's history could hypothetically match the kind of global disruption an industrial society might cause. For example, the Paleocene-Eocene thermal maximum, about 56 million years ago, involved a sudden and massive release of carbon into the atmosphere. It caused a rapid rise in global temperatures and major changes in ecosystems. Scientists still debate the cause. Was it volcanic, methane release, something else? Again, no one is suggesting it was caused by ancient industry, but the point is, it's difficult to rule things out with certainty, and that's what makes the Silurian hypothesis powerful. It's not a claim, it's a reminder that the deep past is mostly gone, and that our assumptions about what's possible are shaped by what we can still see. In the end, Schmidt and Frank concluded that we should pay more attention to these questions, not because we're likely to discover an ancient industrial species, but because studying what kind of traces we will leave behind can help us understand the planet better. What will future scientists, millions of years from now, be able to learn about us? What signals will we leave in the rocks? And perhaps more importantly, if Earth has already hosted one advanced civilization, what does that say about the future of ours? The Silurian hypothesis doesn't give us answers, but it gives us permission to ask the questions carefully, logically, and without embarrassment. And sometimes in science, that's where real discovery begins. Buried too deep to find. If an ancient civilization had ever walked the Earth long before the dinosaurs, it wouldn't just have to survive the test of time. It would have to survive the Earth itself. And that might be the hardest part of all. Because Earth, despite how solid it feels under our feet, is not a static planet. It's constantly moving, shifting, folding, and recycling its own surface. That means the past doesn't just fade, it gets buried, crushed, and in many cases completely erased. This is the part that most people don't realize when thinking about ancient history. Earth doesn't preserve things easily, unlike Mars or the Moon, which have no atmosphere, no plate tectonics, and very little erosion. Earth is constantly changing. Oceans move, mountains rise and fall, entire continents drift across the globe, and beneath all of that, the crust itself is being pulled inward, down into the mantle, where rock melts and reforms over millions of years. This process is called subduction. It's one of the main engines of plate tectonics. Where one tectonic plate slides under another, the crust is dragged deep into the earth and slowly destroyed. Anything that was on that land, cities, fossils, even entire mountain ranges, goes with it. Eventually it turns to magma, becomes part of a new rock layer, or gets lost in the heat and pressure miles beneath the surface. And it's not rare. In fact, most of Earth's surface gets recycled this way over geologic time. The ocean floor, for example, is surprisingly young, even though Earth itself is over 4.5 billion years old. There is almost no oceanic crust older than 200 million years. It's constantly being created at mid-ocean ridges and destroyed at subduction zones. That means if a civilization ever lived near the coast, or on what is now the seafloor, which is where many human cities are today, its remains would be long gone, not buried, not hidden, just recycled, melted, gone. Even on land, the story isn't much better. Let's say a civilization existed 300 million years ago. Maybe they built with wood, stone, or even metal. Maybe they had tools, homes, roads, machines. Over time, even the strongest materials decay. Iron rusts, wood rots, stone breaks down under weather. Eventually, what remains gets buried by layers of sediment. That sediment turns to rock, and if the area is geologically active, it gets folded, faulted, or pulled into the earth. You might think that artifacts could still survive in caves or other protected spaces, and in rare cases, they might. But we're talking about timescales so vast that even caves collapse, fill in, or get sealed under kilometers of rock. Earth is patient. It waits. And even the most resilient structures eventually lose the fight against time. So when we search for signs of deep time civilizations, we're not just looking through history, we're looking through the after effects of geological amnesia. Earth has no memory unless something is preserved in just the right way, in a location stable enough to avoid destruction, with materials durable enough to last, and in conditions favorable to fossilization or mineral replacement. It's an incredibly narrow set of requirements. That's why the fossil record is so patchy. Even when it comes to living creatures, we often have nothing but teeth, bones, or impressions in mud that happen to harden at the right moment. Now imagine trying to find evidence of culture, intelligence, or industry in that same framework, especially from a time period far older than the age of mammals. The deeper the evidence, the less accessible it becomes. Geologists drill into deep rock cores and study exposed cliffs to find ancient layers, but even those only scratch the surface of Earth's hidden past. And many of the oldest, most stable rocks, like the cratons in Canada, Australia, and Africa, have been weathered and transformed so many times that they may no longer preserve fine details. Even if we did stumble upon something strange, a layer with unusual metals, an out-of-place artifact, a fossil that doesn't fit, how would we interpret it? Would we recognize it for what it is? Or would we assume it was a natural anomaly? Our understanding of deep time is built around expectations. We tend to see what we expect to see, and anything that doesn't fit often gets set aside as a curiosity, not a revelation. This is not to suggest that scientists are ignoring evidence. It's that the evidence we're talking about might be too deep, too degraded, or too strange to be recognized for what it is. We may not be looking in the right places, or we may be walking right past the clues without realizing they're even there. And perhaps the most haunting idea of all is this: the Earth may be the perfect place for life, but it's a terrible place for preserving the memory of that life. Time doesn't just bury the past, it devours it. So if there was a civilization before the dinosaurs, intelligent, complex, perhaps even advanced, it wouldn't just be old, it would be buried beneath billions of tons of pressure, erased by subduction, smoothed out by heat, and rewritten by new rock. Not hidden, not mysterious, just gone. But that doesn't mean it never happened. It only means we haven't found it yet. The problem with artifacts. Whenever the idea of an ancient lost civilization is mentioned, the natural reaction is to ask, where's the proof? If a society once existed long before the dinosaurs, where are their buildings, their tools, their machines? Where are their artifacts? It seems like a reasonable question. After all, human history is full of artifacts. We've dug up pottery shards from 10,000 years ago, stone tools from early humans, and even cave paintings that survived the Ice Age. If we can find those, why can't we find something from a civilization that supposedly lived 300 million years ago? The answer lies in the uncomfortable reality that artifacts don't last forever, and that even the most durable human-made objects are incredibly fragile when stretched across deep time. Let's start with what artifacts are made of. Most human tools, structures, and products are built from materials that degrade naturally. Wood decays, cloth disintegrates, leather, paper, rope, all of it falls apart quickly without preservation. Even materials we consider strong, like metal, plastic, or glass, have their limits. Iron rusts, aluminum corrodes, glass becomes brittle. Plastics, although relatively new, can break down under UV radiation and exposure to air, left unprotected. Even our most advanced creations would crumble within a few thousand years. Now imagine a span not of thousands, but hundreds of millions of years. It's not just time that destroys artifacts. It's the planet itself. Rain wears down surfaces. Wind erodes entire landscapes. Plants grow into cracks and split apart stone. Animals dig, chew, and crush. And under the Earth's surface, there are even more powerful forces at work: pressure, heat, chemical reactions, and shifting rock layers. Even in the best-case scenario, say an object is buried deep in sediment, where it's protected from weather and oxygen, it still faces serious challenges. Over time, that sediment hardens into rock. The object inside might be compressed, mineralized, or dissolved entirely. And if the region is later subject to volcanic activity, mountain formation, or tectonic uplift, the entire record can be destroyed or scattered beyond recognition. It's important to understand just how rare fossilization and preservation really are. Paleontologists know that the fossil record represents only a tiny fraction of the life that's ever existed. Most species left no trace at all. Even dinosaurs, some of the largest creatures to ever walk the earth, are known from incomplete skeletons and scattered bones. Soft tissues are almost never preserved. Entire species may have come and gone without leaving behind a single fossil. Now ask yourself, if bones barely make it through deep time, what chance does a metal tool have? And even if something did survive, something truly artificial, how would we recognize it? Over millions of years, objects become distorted. Metal might oxidize into a blob of reddish rock. Glass could fracture into grains. Complex electronics could break down into trace elements. The clean, manufactured shapes we associate with tools and devices would be long gone. What we'd be left with is a strange lump of mineral with unusual properties, something a geologist might glance at, catalogue as a curiosity, and move on from. It's also possible that if a prior civilization existed, they didn't use materials like we do. Our industrial world is based on combustion, fossil fuels, metals, plastics, and electricity, but that's only one path of development. A different species might have built with biological materials, engineered substances designed to break down cleanly, or maybe they lived in the oceans and manipulated their environment without permanent structures. Maybe their form of intelligence didn't involve machines at all. That sounds speculative, but it's not science fiction. Even on Earth today, some of the most advanced forms of natural engineering come from animals. Termites build massive mounds with internal air conditioning. Beavers engineer dams that transform landscapes. Octopuses can problem solve and manipulate objects without ever building anything permanent. Intelligence doesn't always leave a mark, and when it does, the mark is often temporary. There's another issue too. We only dig where we expect to find something. Archaeologists and paleontologists don't dig randomly. They focus on known sites, fossil beds, sediment layers from known periods, places where earlier discoveries have been made. There's logic in that. But it also means we may be ignoring places where the truly strange remains. The ones that don't fit our expectations are hiding. So the problem with artifacts is twofold. First, very few would survive the gauntlet of deep time. And second, even if they did, we might not recognize them, or we might misinterpret them as natural formations. In some rare cases, people have found things that seem out of place: odd metal spheres, shapes embedded in rock, unusual patterns in stone. But without a clear context, these finds are usually dismissed, explained as natural or labeled as hoaxes. And perhaps most of them are, But even if one or two were real, how would we tell? This doesn't mean we should throw out science or leap to wild conclusions. It just means we should admit a basic truth. The deeper into time we look, the less we can rely on traditional archaeology to guide us. Artifacts are evidence, but only if they're still there, and only if we know what we're looking at. And if something intelligent once lived on this planet long before us, its legacy may not be in its buildings or tools, but in something much harder to see. Tools older than bones. When we think of ancient tools, we imagine stone axes, carved spears, or perhaps the sharp flint edges left behind by early humans. These artifacts feel old to us, sometimes tens or even hundreds of thousands of years old. But in geological terms, they are unimaginably recent. They exist within the thin top layer of time, the visible dust on Earth's vast historical shelf. The real question is not how far back we found tools, but how far back they could have existed, even if we haven't found them yet. The earliest known stone tools made by hominins, our distant ancestors, date back about 3.3 million years. They were simple but unmistakably shaped by intention. A rock struck to make a sharp edge, a groove carved with purpose. These marks separate nature from intelligence. But even then, preservation is rare. These tools only survived because they were made of stone, left in just the right place, and discovered in just the right way. Now, let's rewind the clock, not millions but hundreds of millions of years, back to a time before mammals, before reptiles. Even before the dinosaurs, could tools or something like them have existed that far back? The idea sounds extreme, but that's only because we think of tools in human terms. We think of them as something held in a hand, shaped by fingers, designed to strike, cut, or build. But that definition is too narrow. A tool is any object used to extend the capabilities of a living being, and intelligence doesn't have to look like ours. In fact, even today many animals use tools. Birds bend twigs into hooks. Sea otters use rocks to crack open shells. Chimps sharpen sticks to hunt. Crows drop nuts onto roads so cars can break them. Octopuses carry coconut shells for shelter. These creatures aren't human, but their behavior shows the kind of intelligence that might over time evolve into something much more complex. So now imagine this kind of intelligence, problem-solving, tool-using, environmental, evolving millions of years earlier than we thought possible. Maybe it wasn't mammalian, maybe it wasn't even land-based, maybe it came from an entirely different branch of life. One that rose and fell long before anything like a human ever existed. If such a species reached a level where it created tools, not just for food or shelter, but for shaping its world, what would those tools look like? More importantly, what would they have been made of? Stone, metal, and bone are our markers. But what if a civilization used materials that don't fossilize? What if their tools were biological, extensions of their own bodies? What if they manipulated matter at a microscopic level, crafting organic technology that broke down naturally over time? What if their creations were never meant to last? Our industrial age assumes permanence. We build cities and plastics and steel frames, but a different kind of intelligence might have evolved in complete harmony with its environment, developing tools that vanished as easily as fallen leaves. And if that sounds far-fetched, consider this. Fungi can break down plastics. Bacteria can digest metal. Entire ecosystems exist that feed on the waste of our world. Nature already knows how to clean up after us. So why couldn't an ancient civilization have created tools designed to disappear, either on purpose or simply because they didn't see permanence as necessary? Even within human history, we know this to be true. Many cultures used materials that have long since disappeared: wood, fabric, earth, plant fibers, animal skin. Their tools, weapons, and homes decayed completely, leaving behind no trace unless they were somehow fossilized or protected. We've found entire ancient settlements only because a fire hardened their clay floors, or because dry conditions preserved the walls. Otherwise, they might have gone completely unnoticed. So when we talk about tools older than bones, we're not necessarily searching for stone hammers in ancient rock. We're looking for the possibility that intelligence has emerged before, and that its signature may have looked nothing like ours. Maybe it was fleeting. Maybe it left behind no physical legacy. Maybe the tools were made from sound, water, magnetism, or chemistry. Maybe they altered their environment not through machines, but through subtle changes in biology or behavior, changes that don't fossilize, but still left an impact. And even if some trace remains, a mark in the sediment, a layer of strange mineral concentration, a structure embedded deep in ancient rock, how would we ever connect that to a thinking mind? A single out-of-place artifact isn't enough. We would need a pattern, a consistent signal across time and geography. But with so much of Earth's surface gone, buried or broken, that signal might never be strong enough to see. Still, the question remains. If tools can predate bones, and if intelligence can take many forms, then perhaps we've been looking too narrowly. Perhaps the story of Earth's past isn't just about what we've found, but about what we never learned to recognize. Ancient tech, gone. It's tempting to think that technology, once invented, leaves behind obvious, permanent proof. But the truth is, technology is far more fragile than we like to admit. It's not the shiny smartphone in your hand, or the skyscraper on the horizon. It's the systems, the materials, the connections behind them. And when you strip those away, even the most advanced civilization can disappear without a trace. If an ancient, intelligent species once developed technology before the age of dinosaurs, their entire legacy might have crumbled into dust long before the first dinosaur egg hatched. Modern human civilization, for all its power, has only been industrial for about 200 years. That's a blink. Think about that. Our satellites, airplanes, digital infrastructure, global power grids, all of it has emerged in the last couple of centuries. But imagine pressing pause on humanity today. No more electricity, no maintenance, no people. What would happen? Within a few years, buildings would begin to collapse. Nature would take over. Plants would burst through concrete. Animals would return. Within a century or two, most structures would be in ruins. Cars would rust. Plastics would crack and fade. Skyscrapers would buckle under their own weight. Subways would flood. And without electricity, digital information, all our history, culture, and knowledge stored on servers, hard drives, and magnetic tapes would become unreadable. Even books and paper would eventually rot away. Now stretch that process out across deep time, not just hundreds, but millions of years. Entire mountain ranges rise and fall in that span. Rivers change course. Oceans expand and retreat. Glaciers scrape continents bare. Volcanic eruptions bury entire regions. In this context, even something like a nuclear power plant wouldn't survive as a recognizable structure. It would collapse, corrode, and eventually be buried, or dragged into the Earth's mantle by tectonic forces. What's left might be trace radiation, an odd blip in a rock layer, or nothing at all. So if an ancient civilization did develop technology, what would still be here? Not the machines, most likely, not the buildings, not the electronics, even plastics, which we assume last forever, degrade under heat, sunlight, and microbial action. If a past species used synthetic materials, there's a good chance those compounds broke down completely or were absorbed into the geological matrix. And if their tech was organic, say based on biotechnology or smart biological interfaces, it would have broken down even faster. The more advanced it was, the more integrated it might have been with nature, and the more likely it is that we'd never find it. There's another possibility too. What if their technology wasn't physical in the way we understand it? We assume that all intelligent beings would build machines. But what if that assumption is wrong? What if instead of external tools, they developed inward, mentally, biologically, cognitively? What if their tech was built into their bodies or minds through neural control, chemical signals, or structures that existed temporarily and dissolved after use? A civilization like that might leave behind almost nothing physical. Their power, progress, and memory could have existed entirely within themselves, passed through generations in ways we wouldn't recognize as technology. Even if they had conventional technology, things we'd consider advanced, it's entirely possible that they didn't build on a massive scale. Our civilization builds up cities, towers, networks, but another intelligent species might have developed differently. Perhaps they lived in small, dispersed communities. Maybe they built underwater or underground. Maybe their power came from geothermal energy or biological fusion. Maybe they didn't dig mines or lay highways. Their footprint could have been minimal by design, an intentional harmony with the environment rather than domination over it. And then, just as suddenly as they rose, they could have vanished. A slow extinction, a runaway climate shift, a gamma ray burst from space, a biological collapse, an asteroid. Or maybe, like us, they simply pushed too far too fast. The result would be the same: their technology, their culture, their presence, gone. Not because they never existed, but because they didn't last. Because deep time doesn't care how smart you are. The scary part is that we already know this could happen. If humanity vanished today, future archaeologists, 1,000,000 years from now, if there were any, might find only strange chemical residues in deep rock layers, some fossilized landfills, maybe a few oddly layered sediments filled with microplastics and metals. No servers, no computers, no cities, no people, just anomalies, curious, but not conclusive. And they might wonder, was there once a thinking species here, or is this just geology playing tricks? So when we look at Earth's deep past and find nothing but rock and silence, we shouldn't be too sure of what that silence means. It might not mean no one was here. It might just mean they didn't leave behind the kind of proof we're expecting. Technology, as powerful as it is, doesn't guarantee a legacy. It guarantees function for a while. After that, it depends on luck, on geology, on timing, and on whether anyone is still around to remember. In deep time, even the brightest lights eventually go dark, and maybe once, long before us, one already did. The intelligence before us. When we talk about intelligence, we often treat it like something exclusive, something that happened once, and only once with us. Humans are the clever ones, the tool makers, the language users, the planet shapers. Everything else we assume falls somewhere lower on a scale we built ourselves. But what if that view is too narrow? What if intelligence isn't rare, but recurring, something that nature explores again and again, only to wipe it away and start over? If that's the case, then maybe we're not the first. Maybe we're just the most recent chapter in a story that's been written and erased more than once. We like to imagine intelligence as a linear progression, a slow climb from simple to complex, from instinct to thought, from animal to human. But the fossil record doesn't always support that kind of steady upward path. Life doesn't just evolve, it collapses and restarts. 5 times in Earth's history, mass extinctions have wiped out most species on the planet. Each time, evolution took a different direction afterward. The dominance of fish gave way to amphibians, then reptiles, then mammals. Each group had its moment. Each one, in theory, had a chance to develop something more, something like us. So why should we assume that intelligence has only happened once? Even today, there are animals that show remarkable cognitive abilities. Octopuses solve puzzles, recognize individual humans, and escape from sealed containers. Elephants mourn their dead and show signs of empathy. Crows and ravens make tools and plan for the future. Dolphins understand symbolic language and pass knowledge between generations. None of them are human, but all of them are undeniably intelligent in their own way. Now imagine giving one of those species a few 100 million years. What might they become? It's entirely possible that in the deep past, long before the first dinosaur, some lineage reached a similar tipping point. Not identical to us, but comparable. The moment where awareness deepens, where individuals begin to plan, to imagine, to shape their surroundings intentionally. Maybe it was a reptilian species during the Permian. Maybe it was something soft-bodied and now completely forgotten from the Precambrian seas. Maybe it was aquatic and left no trace because it lived in places where preservation is least likely. Coastal wetlands, shallow oceans, muddy estuaries. And maybe, just maybe, it built something, thought something, dreamed something, then vanished. The problem is that we expect intelligence to look like us. 2 arms, 2 legs, a brain and a skull, a society with buildings and roads and writing. But evolution doesn't repeat in exactly the same way. It reuses patterns, but it adapts to conditions. So an earlier intelligent species might not have had hands or vocal cords. It might not have used fire or tools. Its intelligence might have emerged in a different form, visual, chemical, even vibrational. Its society might have been decentralized, like a hive mind, or embedded in networks of shared behavior. It might have communicated in frequencies we can't detect or left behind structures we'd mistake for natural formations. And even if it did build things, structures, systems, technology, those things may have disappeared long ago, or they may still be out there, unrecognized. A straight line of stones in a desert, a repeating pattern in an ancient sediment layer, a mineral concentration that doesn't quite fit. We walk past these things because they don't match our definition of intelligence. But that doesn't mean they aren't signs of it. There's also the unsettling idea that intelligence might not always lead to survival. We think of our technological prowess as the pinnacle of evolution, but it also puts us at risk. We change our environment faster than we can adapt to it. We consume, pollute, alter, and destabilize. If a previous intelligent species followed a similar trajectory, it might have met the same wall we're racing toward: resource depletion, climate collapse, loss of control. And once it fell, time took over. The remains crumbled. The land shifted, the traces scattered. So perhaps we shouldn't be asking whether intelligence ever existed before us. Perhaps we should be asking how many times it has, and how many times it has been lost. There's no solid proof yet. No fossilized brain case with tool marks. No ancient tablet buried beneath miles of rock. But maybe the proof is subtler. Maybe it's in the way life keeps trying, the way complexity keeps re-emerging, the way minds keep forming, again and again, in oceans, forests, deserts, and skies. Maybe Earth wants to think. Maybe it's tried before, and maybe for a little while it succeeded. But intelligence isn't a guarantee of permanence. In fact, it may be the opposite. Consciousness brings with it both creation and destruction, insight and arrogance, power and instability. And if we are the latest iteration of Earth's intelligent species, then it's not just our future at stake. It's our place in a cycle we're only beginning to see. We may not be the first, And if we're not careful, we may not be the last. The mystery of bizarre fossils. Most fossils fit into our neat categories. Plants, bones, shells, teeth, tracks, all easily placed within the branches of life as we understand it. But every so often, something strange turns up. A shape that doesn't fit. A pattern that doesn't make sense. A structure that looks engineered or organized or simply too unusual to be dismissed outright. And while most of these are eventually explained away as natural anomalies, the truth is, many remain unresolved. They sit quietly in museum drawers or university collections, labeled with vague terms like problematic fossil or unclassified specimen. They are the geological equivalent of a shrug, a silent reminder that not everything in the fossil record has been figured out. These anomalies are often brushed aside, not because of a lack of curiosity, but because of the sheer weight of scientific expectation. Paleontology is a field built on careful, methodical classification. You find a bone, you measure it, you compare it to known species, and you place it in the evolutionary tree. But when something shows up that doesn't belong on the tree, or worse, seems to come from a branch we didn't even know existed, it becomes uncomfortable. Scientists are trained to be skeptical of wild claims, and rightly so, but that skepticism sometimes creates blind spots, especially when the strange fossils don't resemble anything alive today. Take the Ediacaran biota, for example. These are some of the oldest known complex life forms, dating back over 570 million years, and yet many of them don't look like animals or plants or fungi. They're soft-bodied, symmetrical, and often fractal in shape, with no clear mouth, no limbs, and no obvious way of reproducing. Some look like leaves, others like discs or tubes. For decades, scientists have debated whether they were an early attempt at animals or something entirely separate that has since gone extinct, without leaving descendants. They're often categorized as extinct experiments, evolutionary dead ends. But what if they were something more, not intelligent, necessarily, but different, a form of life that doesn't fit into the biological frameworks we use today? And if that's possible, how many other oddities have we misunderstood? There are other examples. Fossils with unusual mineral patterns, symmetrical grooves, or geometric structures. Some look like gears, others resemble wires or spheres. A few appear in rock layers so old that no multicellular life was supposed to exist at the time. Most are dismissed as pseudofossils, rock formations that just look like something biological. Iron nodules, mineral veins, crystal growths, and often that's exactly what they are. Nature is good at creating order from chaos, but now and then, even experts admit this one's a bit strange. A famous case is the metallic spheres of Klerksdorp, found in South African mines. These small grooved balls were discovered in Precambrian rock, estimated to be over 2.8 billion years old. Their perfect shape and symmetry puzzled many. Some believed they were man-made, despite the fact that they predated any known human technology. Scientists eventually concluded that they were natural formations, the result of mineral growth under high pressure. But the mystery still lingers. How did nature create such uniform, balanced shapes, with equidistant grooves, without any intelligent input? Then there are the so-called out-of-place artifacts, or OOP arts, items claimed to have been found in rock layers far older than any civilization. A nail in a block of ancient stone, a tiny gold figurine resembling an aircraft, a piece of machined metal embedded in coal. Most of these claims come from unreliable sources. Many have been debunked, misdated, or revealed as hoaxes, but a few remain unresolved, sitting at the fringe of scientific discussion, not embraced, not studied deeply, just avoided, because to take them seriously would require challenging the entire timeline of human existence. And that's the real problem, not with fossils but with expectations. We expect ancient life to be simple, We expect anything intelligent to be recent, so when something odd shows up, the instinct is to fit it into the known story, or to ignore it entirely. This doesn't mean scientists are hiding the truth. It means that science, like any system, has boundaries. It works best when things follow the rules, but anomalies don't follow rules. They raise questions that don't have neat answers, and in a world built on evidence, uncertainty is uncomfortable. But maybe we need to lean into that discomfort, not to jump to conclusions or embrace pseudoscience, but to stay open, to admit that the fossil record is incomplete, that preservation is rare, that time is long, and that somewhere in a rock layer we haven't drilled yet, or a fossil drawer we've forgotten about, there might be something that doesn't just challenge our timeline, but rewrites it. It might be a structure that shows signs of engineering. It might be a shape that implies symmetry too perfect for chance. It might be a fossil that looks more like a machine than a life form. Or it might be something so strange, so alien to our way of thinking, that we wouldn't even recognize it as a clue. The fossils we understand tell us the story we already know, but the ones we can't explain, those quiet, bizarre outliers, might be trying to whisper something very different. The carbon fingerprint. When it comes to leaving a mark on the Earth, nothing defines our modern civilization quite like carbon. We burn it, we build with it, we breathe it out, and pump it into the skies. It runs through every corner of the industrial world, from the fuel in our cars to the plastic in our clothing. And long after our buildings collapse, long after our machines rust, this carbon trail might be the only thing that survives. A shadow in the rocks, a subtle shift in chemistry, a fingerprint left behind not in stone, but in the atmosphere, the oceans and the layers of sediment slowly settling over time. And if we can leave that kind of trace in just a few centuries, what might a civilization before us have done if it too had burned, built, and altered the balance of life on Earth? This is the idea behind the carbon fingerprint. It's not about fossil remains or ancient ruins. It's about chemical evidence, the invisible changes that intelligent life leaves behind. Every species interacts with its environment, but industrial civilizations do something different. They disrupt the global systems. They extract fossil fuels and release carbon that's been buried for hundreds of millions of years. They change the very composition of the atmosphere, and those changes don't just vanish. They get locked into rocks, sediments, and ice, creating a chemical timeline that geologists can read, like rings in a tree or layers in a cake. Today, we're creating what scientists call the Anthropocene, a proposed new epoch that reflects the massive impact humans have had on the planet. And one of the main markers of this epoch is a rapid shift in carbon isotopes, specifically the ratio of carbon-13 to carbon-12. Plants preferentially absorb carbon-12, so when we burn fossil fuels, which are the remains of ancient plant life, we release a flood of light carbon into the atmosphere. That changes the global carbon ratio, and this change gets recorded in marine sediments and carbonate rocks. Now here's where it gets interesting. When scientists look back through deep time, they sometimes find similar disruptions, sudden shifts in carbon isotope ratios that suggest something big happened. One such event was the Paleocene-Eocene thermal maximum, or PET-MN, about 56 million years ago. During this period, the planet rapidly warmed, the oceans acidified, and many species went extinct. The cause, we're not sure. Some say it was volcanic activity, others blame methane released from oceanic sediments, but the carbon fingerprint looks oddly familiar, a rapid release of light carbon, similar to what we're doing today. And this raises a question that makes scientists pause. What if we're not the first to do this? The Silurian hypothesis, which we discussed earlier, touches on this possibility. If an ancient industrial civilization had once existed, we might not find their cities or their machines, but we might find their chemical impact, their carbon spike, their disruption of the Earth's natural cycles, not because they meant to leave it, but because it's impossible to burn that much carbon and not be noticed, even millions of years later. Of course, this kind of evidence is circumstantial. A carbon spike alone doesn't prove the existence of a civilization. Natural causes can do the same thing. Volcanoes can release vast amounts of CO2. Methane clathrates can destabilize. Even asteroid impacts can trigger massive carbon disruptions. Heinous. So we can't just look for the signal, we have to look for the pattern. Is the carbon release accompanied by other changes? New minerals that don't occur naturally, synthetic compounds, unusual trace metals? If so, that might point to something artificial. If not, it may just be nature doing what it has always done, shifting, collapsing, rebuilding. But there's something else to consider. If we, with just 2 centuries of industrial activity, have already left a detectable mark on the Earth's chemical makeup, then it wouldn't take much more to leave a similar trace in the deep past. A civilization that lasted only a few thousand years, a blink, geologically speaking, could leave a carbon fingerprint just like ours. And if they were more efficient, more environmentally integrated, or shorter lived, their signal might be even fainter, just enough to raise questions, but not enough to answer them. That's what makes the search so difficult. The past isn't just buried, it's mixed with noise. Countless natural processes have left similar signatures across Earth's history. Carbon comes and goes, oceans rise and fall, temperatures swing, and within that chaos, we're looking for a subtle echo, something that whispers we were here. The carbon fingerprint is not definitive proof of an ancient civilization, but it might be the only kind of proof time is willing to preserve. It doesn't fade as quickly as structures. It isn't lost like languages. It's chemistry. And chemistry, once written into the Earth's systems, can endure for millions of years. So when we dig into ancient rock and find an unexplained carbon spike, maybe we should pause. Maybe we should ask, not just what caused it, but who might have caused it. And even if the answer turns out to be volcanic, or biological, or unknown, the act of asking changes something. It opens a door, because if carbon is the fingerprint of civilization, then Earth's rocks may hold far more signatures than we ever imagined. Geological evidence of the unknown. Everywhere beneath our feet, the Earth stores stories. Not in words or symbols, but in layers of rock, sediment, and mineral. Each layer is a frozen moment in time, a quiet snapshot of what the world looked like when that sediment settled, or when that lava cooled, or when that ocean dried up. To a geologist, the planet's surface is like a vast, sprawling library with no labels, only patterns, chemistry, and texture. Most of the time, these stories make sense. They tell of volcanoes, of ancient oceans, of forested swamps that became coal beds. But now and then, in the midst of all that order, something strange appears, something that doesn't fit, something that seems to say, there's more to this than we understand. These geological anomalies come in many forms. Some are layers of rock with chemical signatures that defy easy explanation, spikes in certain metals, unexpected isotope ratios, unusual mineral formations. Others are physical structures, layers of fused material, abrupt changes in sediment type, or perfectly flat, layered surfaces that resemble concrete more than natural stone. In isolation, Each of these might be explained away, but taken together, they form a quiet catalogue of the unexplained, a list of questions the Earth doesn't quite answer. One of the most famous examples is the banded iron formations, or BIVs, found in some of the oldest rocks on Earth. These ancient layers alternate between iron-rich and silica-rich bands, formed over 2 billion years ago. We know they're related to the rise of oxygen in Earth's atmosphere, a byproduct of early microbial life, but the precision and scale of these layers still baffle scientists. It's a natural process, yes, but it shows us how life can imprint itself on rock in ways that last for eons. If microbes could do that, what could an intelligent civilization do? Another mystery lies in the form of spherules, tiny spherical particles found in certain rock layers. Some are clearly the result of asteroid impacts, their round shape formed by molten droplets, cooling as they fall through the atmosphere. But others appear in layers without any known impact or volcanic event. Some of these are metallic, with unusually high concentrations of elements like nickel and chromium. The most conservative explanation is that they formed from some kind of natural high-energy event. But others have quietly wondered, could some be industrial in origin? Could they be the scattered remnants of ancient processes, combustion, metallurgy, or even manufacturing, now reduced to microscopic clues? Then there are the polystrate fossils, tree trunks or plant remains found standing upright through multiple layers of sediment, sometimes spanning what appears to be thousands or even millions of years' worth of deposition. These fossils are often explained as the result of rapid burial in flood-like events, and that's a reasonable explanation. But the fact that organic material can survive such disruption, stretching across so much geological time, is a reminder preservation is possible under the right conditions. If a tree can make it through shifting layers, could something artificial, something engineered, do the same? In other places, we find glassified rock layers, stone that appears to have been melted and fused in place, then rapidly cooled. Natural causes like lightning strikes, meteor impacts, or volcanic eruptions can explain many of these. But a few are still debated. Some ancient layers of fused silicates are flat, widespread, and appear almost industrial in their consistency, like a primitive form of vitrification. If an ancient civilization had access to high-temperature technology, furnaces, reactors, even something like atomic testing, would it leave behind a similar mark? And what about mineral veins that contain elements we associate with modern industry, rare earths, refined metals, trace chemicals that don't naturally occur in concentration? Most of these are formed through slow geologic processes, hydrothermal fluids moving through cracks, depositing minerals over time, but occasionally, concentrations show up in ways that don't fully match expected models. They're explained as anomalies, or they're quietly filed away. But the question remains, if you were to look for the leftovers of ancient mining, ancient refining, or even ancient dumping, what would you expect to see? A metallic vein in bedrock, or a concentration of rare elements where no such deposit should exist? These are not smoking guns, they are whispers. They are the quiet geological evidence of something unusual, and whether that something is ancient industry, or extreme volcanism, or just a quirk of nature, we don't always know. What makes them so fascinating is that they sit on the edge of certainty, not enough to rewrite the textbooks, but just enough to stay in the footnotes. And perhaps that's where the truth lives, not in dramatic ruins or fossilized machines, but in the margins of Earth's geological record, in layers we haven't looked at closely, in samples we've dismissed as noise, in data we gathered, but never understood. Geology isn't just the study of rocks, it's the study of time, memory, and transformation, and sometimes within that memory are fractures, pieces that don't belong, not because they're wrong, but because they hint at a version of the past we haven't considered. If a civilization existed before the dinosaurs, it would have had to leave its mark here, not in story or language, but in stone. And maybe, just maybe, we've already found part of that mark. We just don't realize it yet. Why would they disappear? Even if we open our minds to the idea that a civilization might have existed before the dinosaurs, that it left behind no buildings, no writing, no machines, but only the faintest chemical or geological traces, one big question remains: why would it vanish? If they were intelligent, advanced, capable of shaping their world, then why wouldn't they endure? Why didn't they last? Why isn't there a single, undeniable artifact to prove they were ever here? It's a fair question. After all, we think of intelligence as the ultimate evolutionary advantage, the thing that lets us outwit nature, solve problems, survive. But that may be a bias. Intelligence doesn't guarantee permanence. In fact, it may come with a built-in vulnerability, the ability to alter the environment so completely that it becomes unstable, or the tendency to push past natural limits faster than a planet can handle. The smarter the species, the more powerful its tools, and the greater the risk of those tools spiraling out of control. Maybe they disappeared in the same way we fear we might, through environmental collapse, a warming planet, a poisoned ocean, a critical resource overused until the systems around it fell apart. The signs of that kind of end would look eerily familiar: a carbon spike in the geological record, a burst of extinction across multiple species, a sudden shift in climate followed by silence. If such an event happened hundreds of millions of years ago, we might already have found its evidence, but read it only as a natural catastrophe, not a consequence of industry. Or maybe it wasn't environmental. Maybe it was something faster, a biological collapse, a pandemic they couldn't control, a cascade failure in their food system, something microscopic that spread too far, too fast, or something they created themselves, unintentionally or through arrogance. Intelligence gives us the ability to engineer life, to play with genes, to reshape organisms, but with that power comes risk. A single mistake could be all it takes. A civilization might not need war to end itself. It might just need an error it didn't see in time. There's also the darker possibility, one we know all too well from our own history, that they destroyed each other. That intelligence brought division, conflict, weapons, that fear or ideology or competition drove them to war, and not a slow, gradual war, but something faster, something absolute. If they developed nuclear technology, or anything like it, they might have had the power to erase themselves, not just socially, but physically, not just their records, but their landscapes. An extinction by design, not by accident. Extinction by design, not by accident. And if it happened long enough ago, the earth would have healed over the wound, recycled the ruins, buried the memory. But not every disappearance needs to be catastrophic. Some endings are quiet. Maybe they didn't collapse. Maybe they faded. A slow decline, a fertility crisis, a culture that grew disinterested in expansion, that chose to withdraw rather than dominate. They might have become fewer, scattered, self-sufficient, and eventually forgotten, even by their descendants. Maybe they returned to the forest, the ocean, the earth. Maybe they knew something we don't, that longevity doesn't come from rising ever higher, but from stepping gently and leaving little behind. And of course, there's always nature, an asteroid, a supervolcano, a magnetic reversal, a gamma-ray burst from deep space. Earth's history is full of sudden violent resets, events that strike without warning and leave no time to prepare. Even a civilization with foresight and technology might not survive a global flood basalt eruption or an impact event. The question isn't whether they were advanced, it's whether they were lucky. Because sometimes survival isn't about intelligence, it's about timing. Then there's the most uncomfortable possibility of all, that they reached a point where continuing didn't make sense. That intelligence showed them the futility of permanence. That intelligence showed them the futility of permanence. That they understood their place in the ecosystem and chose not to interfere with it. That they developed ethics or awareness that led them to deliberately not dominate the planet. We assume every intelligent species would behave like us, expanding, consuming, recording. But that's a projection. Maybe the most advanced thing a civilization can do is disappear on purpose, leave no damage, leave no mark, leave only balance. It's hard to accept the idea of something intelligent and powerful choosing not to be remembered. But maybe that's because we haven't seen that choice before. Our own path has been one of accumulation, of growth, of visibility, of control. But another path might exist, a quieter one, a wiser one. And if it does, maybe we wouldn't recognize its traces even if we walked over them every day. The truth is, disappearance isn't rare. Most species that ever lived are gone. Most lineages ended without warning. Most civilizations, if they existed, would be erased by time, nature, or their own choices. The Earth is vast, ancient, and forgetful. It records only what it's forced to remember. So if we ever find proof of someone who came before us, it will be a miracle of preservation, a hint that slipped through the cracks, a signal that outlasted silence. And if we never find that proof, it doesn't mean they weren't here. It may only mean that their end was as complete and as quiet as nature itself. Ancient civilizations in myth. Long before satellites, before science, before geology, humans told stories. We've always tried to explain where we came from, what came before, and why the world is the way it is. In every culture, on every continent, ancient myths speak of powerful beings, forgotten ages, and great civilizations that rose and fell before memory. These are not history books. They are oral traditions, symbolic and poetic, passed from one generation to the next. But sometimes, hidden in their rhythms is a strange consistency, a shared whisper that something great existed long ago and that it ended in silence. The most famous of these myths is Atlantis, told by the Greek philosopher Plato over 2,000 years ago. He spoke of a vast, advanced civilization that existed beyond the Pillars of Hercules, what we now call the Strait of Gibraltar. According to Plato, Atlantis was powerful, wealthy, and sophisticated, but its people grew arrogant and corrupt, and the gods punished them. In a single day and night, the island sank beneath the sea. Many dismiss the story as allegory, a moral tale about the dangers of hubris. Others see it as a fictional metaphor for Athens. But the idea that such a tale could survive through oral memory suggests it may be older than it seems, and Plato claimed it came from Egypt, passed to Solon by temple priests, who said it described events from 9,000 years earlier. But Atlantis is not alone. In Mesopotamian myth, the Sumerians spoke of kings who ruled for tens of thousands of years before a great flood reset civilization. The Eridu Genesis lists kings whose reigns stretched impossibly long, durations that only make sense if they aren't literal, but symbolic of vast forgotten times. Then the flood came, sent by the gods, and everything before it was lost. What followed was a restart, a new line of kings, shorter lived, more human. In the Epic of Gilgamesh, too, we find echoes of earlier wisdom and a longing for immortality that seems to mourn not just personal death, but civilizational collapse. Hindu cosmology tells of cyclical ages called yugas. In the Mahabharata and Puranas, we are said to live in the Kali Yuga, the final, most degenerate age in a repeating cycle. Before us came longer, more virtuous ages, the Satya Yuga, the Treta Yuga, the Dvapara Yuga, each lasting tens or hundreds of thousands of years. These yugas were marked by great knowledge, spiritual awareness, and powerful civilizations. As time passed, virtue declined, memory faded, and each age ended in catastrophe or transformation. The timelines here are mythic, not historical, but they suggest a belief that greatness has come and gone before, and that what we now call history is only a fragment of a much older, deeper pattern. In Mayan and Aztec myths, too, we find references to multiple suns or worlds, previous creations that ended in flood, fire, jaguar attacks, or windstorms. The fifth sun, the world we live in now, follows four others that were destroyed. Each world had its own beings, its own people, its own fate. The echoes here are striking: humanity created, lost, recreated. Civilizations rising, falling, returning, time, not as a line, but as a spiral. Even in Native American, African, and Polynesian traditions, there are stories of vanished lands, sky people, ancient knowledge, and gods who once walked the earth. In some versions, people were taught agriculture, language, astronomy, and then those teachers vanished. Were these just metaphors for natural learning, or faint memories of something more? Skeptics argue that myths are just stories, psychological projections, poetic ways of explaining nature, morality, and death. And they're right to a point. Myths are not meant to be read like newspapers. They're symbolic, fluid, shaped by culture and repetition, but that doesn't mean they're meaningless. Even when embroidered, even when changed, stories often carry something forward. A memory, a mood, a shadow of real events that became exaggerated, simplified, or mythologized over time. So what happens when the myths of unrelated cultures all share a common structure? A golden age, a fall, a flood, a reset. Are we just seeing a universal storytelling pattern, or the deep echo of something that really happened, something so far back it passed from history into legend, from fact into metaphor? We may never know, but the existence of these myths, across cultures that never met, in languages that never shared a root, suggests a shared sense of loss, a feeling that something larger, older, more mysterious once existed, that we're not the beginning of the story, but part of its continuation, that there was a time when things were different, not just spiritually, but physically, and that whatever came before is now buried beneath both time and silence. Maybe these myths are just stories, but maybe stories are how civilizations remember things they can no longer explain. And if an intelligent species really did exist before the dinosaurs, if it left behind no metal, no machines, no bones, maybe the only thing that survived was a feeling, a message that echoed through evolution and reached us as fragments, not in science, but in song. Aliens or ancients? When people see something unexplainable, a strange structure, a mysterious artifact, a leap in ancient knowledge, their thoughts often drift to the stars. The unknown becomes extraterrestrial. It's easy to do. The idea that aliens visited Earth long ago is both thrilling and convenient. It provides a ready-made answer to the impossible. We couldn't have done this, they must have. But in reaching for the stars, we often ignore a more grounded, more unsettling possibility. What if the intelligence we're sensing didn't come from out there, but from right here? What if it wasn't alien at all, just ancient? The human fascination with ancient astronauts is deeply rooted in our curiosity. Stories like the Nazca Lines in Peru, the pyramids of Egypt, or the advanced mathematics of early Mesopotamians are sometimes used to suggest outside influence. We see ancient humans doing sophisticated things and assume they couldn't have done it alone, so we invent outsiders, beings with knowledge far beyond ours, descending from the sky. But what if we're misinterpreting the mystery? What if those strange feats, those impossible artifacts, those ancient anomalies weren't the work of visitors, but the leftovers of an earlier civilization? It's a difficult idea to confront because it reshapes our entire sense of history. Aliens allow us to preserve our linear timeline, to keep ourselves at the top, the newest, the best. But an ancient terrestrial civilization, that suggests we're not the pinnacle, just the latest version. That something else might have risen, reached its peak, and vanished, leaving only traces, chemical, mythological, geological, scattered through the earth and our imaginations. There's a reason these two ideas often overlap. When people describe ancient gods, they often sound strangely technological: machines in the sky, beings of light, devices that cause thunder or fire. And over time the literal becomes symbolic, stories evolve. But somewhere underneath it all, there may have been real events, real encounters. And those encounters may not have been with aliens, but with survivors, remnant, echoes of a forgotten intelligence that once lived among the forests and oceans, and then disappeared into silence, or into legend. We assume the default state of the past is primitive, that early humans emerged in a vacuum, discovering everything from scratch, from fire to writing to architecture. But it's possible that we inherited more than we realize, not directly, not through books or tools, but through observation, imitation, stories. If a prior intelligent species lived on Earth, and vanished long before our time, it's possible that fragments of their existence filtered into early human consciousness. A tool found and copied, a ruin misunderstood and mythologized, a behavior mimicked without knowing its origin. And when later generations encountered these fragments, they may have created the only explanation they had: gods, or sky people, or fallen stars, not because they had proof, but because the presence felt other. And when something feels other, but came from here, we tend to assume it came from out there. It's also possible that the idea of aliens is a psychological stand-in, a placeholder for our deeper, unspoken suspicion that we're not the first, that intelligence has come and gone before, that somewhere in Earth's deep past, something like us, or unlike us, but conscious, existed and left just enough behind to make us wonder. The alien hypothesis is seductive. It fuels movies, books, conspiracy theories. But the ancient civilization hypothesis is quieter. It doesn't offer easy answers. It doesn't give us spaceships or messages from the stars. Instead, it suggests that the Earth has a longer memory than we thought, and that we've barely scratched the surface of it. The key difference is origin. Aliens are foreign, external, unknown. Ancients are local, familiar, terrifying in their closeness. If something intelligent lived on Earth, long before us, it wasn't alien in the cosmic sense. It was us, in the broadest definition, earthborn, homegrown, part of the same evolutionary tree, perhaps on a different branch, now cut off, and buried under rock and time. This possibility doesn't require faster-than-light travel or interstellar engineering. It only requires time, and Earth has had plenty of that. 4.5 billion years. That's more than enough for life to rise, evolve, reach intelligence, build something extraordinary, and vanish. So when we look at the stars and ask if we're alone, maybe we're asking the wrong question. Maybe the silence out there is less mysterious than the silence in here. The one buried in our own geological layers, in the myths we half remember, in the fossils we haven't recognized for what they are. Maybe the intelligence we've been looking for has already been here and gone. And maybe in our search for aliens, we've overlooked the oldest mystery of all, not visitors, but predecessors. What if we're not the first? For most of us, the story of humanity feels like a beginning, a rise. We imagine ourselves as the culmination of billions of years of evolution, the first species to become self-aware, to build cities, to send machines into space. We see ourselves as the first chapter of intelligence, the dawn of something new. But what if that assumption is wrong? What if we're not the beginning, but just the latest page in a much older, far longer book? It's a quiet question, but a heavy one, because it doesn't just ask whether someone else came before us. It asks what that means for who we are. If we're not the first intelligent species on Earth, then our history is no longer the foundation. It's a sequel. And everything we think of as progress, as discovery, as innovation, becomes relative. Not new, but new again. The idea that intelligence may have risen more than once on the same planet changes everything. It means that consciousness is not a singular event. It means that Earth is not just a place where life exists, but a place where mind happens, and that it may happen again and again whenever the conditions are right. Like lightning in a storm, sparking into being, and then fading just as quickly. It also forces us to reconsider what we mean by advanced. We measure civilization by what it leaves behind: buildings, tools, infrastructure, power grids. But what if those things aren't the peak of intelligence, just one expression of it? A prior species may have taken a different path, one that was more integrated with nature, less obsessed with permanence, one that didn't leave behind stone monuments or metal towers, not because it lacked the capability, but because it didn't need them. It may have lived in a balance so deep that time absorbed it without resistance. It may have created, flourished, and then chosen to leave no trace. And then we come along, millions of years later, mistaking our noise for uniqueness. We dig into the past and see only absence. No skeletons of thinking beings, no fossilized machines. But that absence might not be proof of nothing. It might simply reflect how little survives, even of ourselves. Strip away our digital records, our electricity, our satellites, and what would remain of us in a million years? Some synthetic chemicals in the ground, a few strange isotopes, maybe a handful of fossilized ruins, in just the right conditions. Nothing that screams intelligence, only subtle clues, the same kind of clues we've already seen in the ancient rocks, but ignored because they didn't come with a label. The deeper you go into Earth's timeline, the more it resembles a book that's been half erased. We can see the chapters, the volcanic ages, the ice ages, the extinction events, but most of the text is missing. Species lived and died without ever being recorded. Entire ecosystems bloomed and vanished without a single fossil. If a civilization had existed during one of those blank stretches, say 500 million years ago, or 800 million, or even 2 billion, we would have almost no way of knowing. The land they lived on could now be buried beneath the seafloor, their artifacts crushed, their architecture ground into minerals, their legacy mistaken for geology. This isn't speculation, it's humility. We know that the earth recycles itself, that the crust we walk on today was once molten, that mountains rise and fall, that oceans open and close, and that time is not gentle with memory. So why do we assume we'd be able to find evidence of a civilization that ended hundreds of millions of years ago, when we struggle to preserve our own knowledge for even a few centuries? If we're not the first, then we have to consider something else. What happens to civilizations like ours? If others have come and gone, then there may be a pattern, a natural lifespan, a point where intelligence becomes its own obstacle, where complexity turns into fragility, where the same traits that let a species rise, curiosity, ambition, expansion, eventually lead it too far. And if that's true, then maybe we're closer to that threshold than we realize. But there's another way to look at it, one that's less bleak and more profound. Maybe intelligence always ends, but its ending isn't a failure, Maybe each civilization that rises is a brief moment of awareness in the planet's long sleep, a spark, a chance for the universe to know itself for a little while. Maybe we're not meant to last forever, but just long enough to ask the big questions, to look up, to wonder, to leave a faint vanishing mark in the dust, not as rulers but as participants. And maybe in some distant future, something else will rise, something new, something different. It will look around, find strange layers in the stone, and ask, were we the first? It won't be, and neither are we, but that doesn't make us less important. It makes us part of something bigger. Searching for shadows. If someone came before us, intelligent, curious, capable, and then vanished, their story would not be told in monuments or legends alone. It would live in the background, in the unnoticed spaces, in the things we overlook. And that's where scientists today are starting to look. Not for cities in the sand or machines beneath the ocean, but for faint, persistent shadows, hidden traces in chemistry, geology, biology, signs so subtle they almost blend into the natural order. This is what the search for ancient intelligence has become, not a quest for objects, but a search for patterns that shouldn't be there. The challenge is enormous. The past is deep, and Earth is a restless place. Rock layers twist, sink, melt, ocean floors vanish into the mantle. Even the land changes shape over time, moving like slow waves across the planet's surface. Most of what was built, grown, or even lived is gone. So the search isn't about finding a perfect fossil of a city or an ancient machine buried in pristine condition. It's about spotting the residue of an anomaly, the kind of thing that shouldn't happen naturally, but did. And when it did, it left behind a question. Scientists are now beginning to ask those questions with a more open mind. The Silurian hypothesis, which doesn't assert that a past civilization existed, but asks how we would know if one did, is part of a growing effort to take the idea seriously without slipping into fantasy. It reframes the question, not was there a lost civilization, but could we tell if there had been one that changes everything? Because suddenly, the task isn't to prove a myth right. It's to understand how intelligence alters a planet, and whether those changes endure. This approach leads to strange places. It means studying carbon isotope anomalies, not just for natural causes, but with a new perspective. Could some of them have been caused by industrial activity? It means re-evaluating mineral concentrations that don't fit known geologic processes, in case they are the byproducts of unknown chemistry. It means asking whether rare earth metals found in ancient layers are from volcanic deposits or something else. It means scrutinizing every known extinction event and environmental shift, not only for volcanic or asteroid signatures, but for patterns of sudden, unbalanced disruption that could hint at technological interference. It also means revisiting synthetic materials, the kind we assume only we can create, and wondering if something similar might have existed before. Today, our civilization leaves behind plastics, novel compounds, altered sediment layers, and artificial isotopes. These are the kinds of things that could, in theory, survive for millions of years under the right conditions. If they've ever existed before, they might still be detectable, but only if we look for them, and only if we know how to recognize them once we do. But the search doesn't stop at the chemical level. It extends into genetics, too. Life remembers things in its DNA. Some researchers are now exploring the idea that if an earlier intelligent species had manipulated genetics, whether to engineer organisms, enhance their own biology, or interact with ecosystems, there might be detectable signs, not obvious ones, not glowing fingerprints, but subtle anomalies in evolutionary paths, unexplained jumps in complexity, or strange genetic markers that seem out of place. It's a kind of archaeology without artifacts, a paleontology of patterns, a science of ghosts. And the truth is, we might already have seen something and simply missed it. There are plenty of unsolved puzzles in Earth's history. Events that don't quite line up with known natural processes. Bursts of change, sudden disappearances. Chemical layers that make sense on one level, but raise questions on another. These things are usually interpreted in the most conservative way possible. And for good reason. Science demands evidence. But when enough little shadows collect in the same corner, we have to at least ask whether they're pointing to something more. That's what this kind of search is. Not a hunt for confirmation, but a sustained willingness to ask strange questions and follow them carefully. To be rigorous, but open. To entertain ideas that sound like science fiction, without letting go of the scientific method. It's not about proving Atlantis or validating myth. It's about humility, about recognizing that in a world as old as ours, the absence of evidence is not always evidence of absence. Sometimes, it's just a sign we haven't looked in the right way, or with the right eyes. And so the search continues. Not in temples or tombs, but in ice cores, deep-sea sediments, mineral veins, and isotope charts. In reanalyzing what we thought we understood. In listening to old data with new ears. We are not just digging for ruins. We are searching for shadows, the kinds that don't cast themselves on sunlight, but on time. And if those shadows turn out to be real, they may change everything we thought we knew about Earth and about ourselves. The legacy we might leave. At the end of all this wandering, the fossils, the myths, the shadows in stone, we're left with a final question, not about them, the ones who might have come before, but about us. If we're not the first, and we're not the last, then what kind of legacy are we leaving behind? What will remain of us when our buildings fall, when our voices fade, when the last light in our cities blinks out, and no one is left to explain what happened? Will anyone or anything know we were here? Right now, we stand at a unique moment. We can fly, communicate across the globe in seconds, sequence DNA, peer into galaxies billions of light years away. We've planted flags on the moon and probes on Mars. We've split the atom and built machines that think. And yet, for all our reach, our grasp on time is fragile. Our civilization, in geological terms, is barely born. 200 years of industry, 100 years of global communication, maybe 50 of space exploration. We are new, young, and uncertain, and like those we imagine might have come before, we are not guaranteed to last. If we vanish tomorrow, every city empty, every machine powered off, the Earth would begin erasing us immediately. Vines through glass, rust on steel, wind and water, breaking it all down. In 10,000 years, most of what we built would be rubble. In a million, even that might be gone, subducted into the mantle, crushed under glaciers, lost beneath oceans. The servers storing our knowledge would rot, the books would decay, the satellites would fall, and the next intelligent species, if one ever rises, might never know we existed. Or maybe they would. Maybe they'd detect the carbon spike in the rocks, the sudden loss of biodiversity, the strange traces of synthetic chemicals and rare isotopes that don't belong. They might wonder, as we do now, about the causes, about who or what altered the planet so suddenly and then disappeared. And maybe they'd tell stories, not about us, but about something like us, something old, powerful, and gone. The idea that we could vanish is humbling. But it's also clarifying. It reminds us that our legacy isn't written in how high we build or how far we spread. It's written in how we treat the planet, each other, and the future. If we are to leave something behind, let it be more than pollution and plastic. Let it be understanding, a record of what we learned, what we struggled with, what we loved. Let it be traces of wisdom, not just waste. Because maybe the most important mark we can leave is not what endures, but what we chose in the face of knowing we wouldn't endure. Maybe the legacy worth preserving isn't in monuments or machines, but in restraint, in compassion, in the awareness that we were part of something bigger, a long mysterious cycle of life and thought that began long before us and may continue long after we're gone. We may be the latest intelligence to rise on this planet, but there's no guarantee we'll be the last. And if someone walks this earth again in the distant future, sifting through the layers, trying to piece together what came before, they won't be looking for declarations or statues. They'll be looking for signs, chemical, biological, geological, of a civilization that cared, on one that saw the deep timeline, and chose not just to burn brightly, but to burn wisely. So what will they find? Will they see a species that lived fast and vanished in chaos? Or one that learned to adapt, to preserve, to look beyond itself? Will our fingerprint be one of collapse, or caution? In the end, we are temporary. All civilizations are. The question isn't whether we will disappear. The question is how we disappear, and what kind of story the earth will tell about us when we're gone. Because long after the last word is spoken, the last city crumbles, the last satellite falls, the rocks will still be here, and the earth will remember, even if it remembers only shadows.